In this video, I like to show why square root of b is b to the 1/2 power. So let's say you don't know what this power is. So let radical b is equal to b to the x. In order to get rid of the radical, we have to square both sides. So what happens here? You get b is equal to b to the x quantity squared is when you have two exponents next to each other, you multiply so you get b to the 2x. And what's the exponent over here? It's invisible, it's 1. So in order to solve for x, what you do is you say 1 equals 2x. And what is your x? X is 1/2. And that was the value that we're looking for. That's why square root of b is equal to b to the 1/2. Using similar reasoning, we could find the nth root of b and change that to a rational exponent. So again, if we want to get rid of the nth root, we have to raise it to the power of n, both sides. So you will get b is equal to b to the xn, and the exponent here is 1, so 1 is equal to xn. Solving for x, you get 1 over n. So nth root of b will always be b to the power of 1 over n. So for example, let's say you have a fifth root of b, then that will be same thing as b to the 1/5. What if you have nth root of b raised to the m power? What is that in, how do you write that in rational exponent? If you want to get rid of m, what you need to do is you need to raise it to the power of 1 over m, both sides. So m and 1 over m cancels out. You get nth root of b equals, you have the two exponents next to each other, you multiply them out, you get x over m. Now how do you get rid of the nth root? Well, you have to raise it to the power of n. So you end up getting b equals b to the n x over m. And in order for them to be equal to each other, you got to set the exponents equal to each other and solve for x, multiplying by m over n both sides, you get m over n. So that means nth root of b raised to the power of m is the same thing as b to the m over n. So for example, let's say you got cube root of b raised to the power of, let's say, 7. That will be the same thing as b to the power of 7 over 3.